Okay, so here we are in chapter 6. Now, chapter 6, it starts off with all the theory behind what's going on, and that's what this is. But ultimately, it all comes down to just being a calculator thing. The entire chapter could be done with the calculator. So don't panic if all these X's and Y's and everything are flying all over the place. Is mostly we won't have to look at those. We're just going to do calculator stuff. But here's what's going on in the chapter. This is a system of equations, and you may have seen that from intermediate algebra or somewhere. And then the question was, okay, well, those equations, those are lines, and if I graph two lines, they should meet at one point. And so if you didn't have the picture and you just had that, someone said, well, what point was that? And if it was in some sort of intermediate algebra class, you had to go through this whole ordeal, and x's go over here, and y's go over here, and multiply through by this, and all this stuff to figure it out. Okay, and then finally you would answer, oh, those two lines meet at the point 5, 4. Okay, so that's what you've done it before, and it was a pain because they didn't tell you there's an easy way to do it on the calculator and not have to manipulate all the numbers and everything all over the place. Now this is the 3D one. I've got X and Y and Z. Okay, so it's in 3D, and I'm not really good at drawing 3D pictures, but basically, if there's pieces of paper, planes, running at all these different angles, they're going to crash into each other somewhere. All right, and if two pieces of paper crash into each other, they're going to crash along an entire line. So maybe if this piece of paper going up and down here crashes into that one, it makes that line right there. And then if the third piece of paper comes sliding in this way, it's going to crash in as well, and it's going to meet at a point like that one. Okay, and so that would have an X and a Y and a Z, and that would be the answer. And if it was a pain to do this, just moving two numbers around and all of that, it's a real pain to do three numbers. Okay, an X and a Y and a Z, and you really don't want to do those by hand anymore. And this is why when they invented computers, it was one of the very first things they did is taught computers to do this. Now, we don't need the X and the Y and the Z. I mean, everyone knows, okay, you got three letters. I can go back and fill those in later. I just need the numbers. Okay, so if I'm looking at that top line there, there's the 5. Now I'm going to write down the X. There's the 4. There's the 3. And there's the -9. Now, I don't need to write the equal sign. I got to keep the negatives. It's got to know about that. That's got to be +1, -2, +2, -6, 1, -1, -1, 3. So that's going to give us a chance to put it into the calculator. I don't have to be messing around trying to get X and Y and Z into the calculator. I'm just going to take all the coefficients, the numbers in front of the letters. I'm going to make sure to keep all the negative signs. Put that into the calculator. The calculator only needs the numbers. It doesn't need the letters. And the calculator will be able to figure it out. Now in the notes, it mentions 3 different methods for this. The first method is RF, which is short for row reduced echelon form, but we'll just keep calling it RF because that's what the calculator calls it. And that's probably the easiest method. You just put it in and it gives you the answer. And then when you're done with that, there's 2 more methods, and you think, but why? I got a method that works. Why would I need another? Especially since the others actually aren't as nice. They're a lot more complicated. And so when we hit them in the notes where we hit to the part where we're supposed to do that, you can always drop back and do every single problem that you could have done using one of those methods using RF instead. So that kind of saves having to learn 3 different methods. I could just learn the RF method and not learn the other 2. Now, one of them is A inverse B. Okay, you take the inverse of a matrix, which sounds really hard, but it's really just the calculator does it. Okay, you could do that. It doesn't take too much longer than RF, but why do I want to take any more time than RF? So we're definitely going to focus on getting A inverse, and I'll show you how to make it work, but really, let's face it, you're just going to keep switching back to doing RF because that's the fast one. And then there's Cramer's rule, and Cramer's rule made a lot of sense before they invented computers, because it's possible to do Cramer's rule and never see fractions until the very end of the problem, which was a big deal when you have to do it by hand. And so I'm just gonna hit on the Cramer's rule that's in the homework, and I'll just do them for you so you can see how they're supposed to be done. But it's confusing, numbers are flying around everywhere, and there's no reason for that when I could just RF everything. So we're just gonna break down the chapter, we're gonna RF, we're gonna do A inverse B, we're gonna do Cramer's rule, but mostly we're gonna RF.